distinguished members, students, and participants of this very important and interesting seminar on AI. In fact, as Professor Jayman mentioned, Dr. Deepak has got a very interesting uh, view on AI, and I'm sure that he's going to share that because today when we speak about AI, we always speak only about technology, and we always speak about how technology is going to change our lives in a very short run. But I think Professor Deepak will give you a very interesting perspective on the development paradigms surrounding that, the ethical challenges surrounding that, and I'm sure that this is going to be a great session and a great learning experience for all of us. Personally, for me, I had a privilege of being working close with Professor Deepak in another project, and I found that he is a excellent thought process, which I believe for our center of excellence, guidance and support of Professor Deepak is invaluable as such. As many of you know that KTU is setting up 3 centers of excellence, one in College of Engineering, Government College, Kannur, where we are setting up on sustainability. One at RIT, Kottayam, where we are looking at materials, and at Model Engineering College, the alma mater of Professor Deepak, on robotics and AI and robotics. And I'm very happy that this lecture is delivered by an alumni of Model Engineering College itself, who has actually made his mark in the AI landscape. So without making a very long speech, I'm sure that all of us are waiting for the talk of Professor Deepak. So over to Professor Deepak, and let me thank you for, I know that you are on a vacation, and still you are sparing time for speaking to all of us. I once again thank you for that, and let's invite you for your session on the AI. Over to you, sir.
Thank you, sir, for your inspiring words. Now I invite our esteemed speaker, Dr. Deepak P, to deliver his talk on AI, a critical introduction.
Many thanks for the introduction, and many thanks to the organizations, and especially Jimon as well for inviting me for this talk. So
I think your audio is not very clear.
Okay, let's see.
It was okay earlier. I think now when you put the
right. Okay. I'll try and speak a little louder. Hopefully.
Yeah.
Okay. Let me know if anything. If it's not clear at some point, and I'll try and maybe switch over to the laptop microphone. I'm using another one right now. Hope it's okay now, isn't it?
Sound is still low.
No, not very clear. Okay. Okay, I'll take out this one.
Yeah, now it is fine.
Okay, I hope it's clear now.
Yeah.
Yes. Thank you very much. Okay, so the title of my talk today is Artificial Intelligence: A Critical Introduction, and I also added an adjective, a gentle introduction, to indicate that I won't be talking about technical. I won't have any equations in these slides. It'll be a fairly light talk in terms of technical, in terms of technological terms. But I hope I'll be able to provide a fresh perspective towards looking at AI, coming from what I regard as a critical political economy studies perspective. So going onto the first slide. So where did AI start? Right. So many of us will point to this person, Alan Turing, who wrote a very impressive paper in 1950 in a journal called The Mind. And his paper was titled Computing Machinery and Intelligence. So in that paper, he was asking this interesting question about, can machines think? Can machines think? Right? That's a very profound question. And towards that, in the first paragraph of the paper, I would encourage you to read that paper. towards understanding AI in a historical level. So in the first paragraph of the paper, he talks about this question. He proposes this question and thinks about how to answer this question. And he sort of says that maybe we should do a Gallup poll and ask people whether machines can think and so on. And then he says that very immediately, he says that that sounds very absurd. What if I ask 100 people and all 100 of them say that machines can think? Does it mean that machines can think at all? And that doesn't mean anything, right? So that is not a way to address this question. And then he switches over to a different question, which is to ask whether machines can create a pretense of thinking, can create an imitation of thinking or thought processes. And then he proposes what is called as the imitation game, which was later called as the Turing test, which we today now know as the Turing test. But before coming to that, I think it's important to understand the context of this question that Alan Turing proposed. He was asking, can machines think, right? So if you think of the word think or reason or intelligence as something that can be attributed only to humans or other living organisms, then you cannot even ask this question, right? So it sounds absurd to ask this question. Can machines think? Is a stupid question. Or to ask if you believe in that kind of a philosophy that only living organisms can think. So there needs to be a philosophical backdrop that is conducive to asking this question about whether machines can think. And that is what we will do. That is what we look over in the next 3 or 4 slides. So if you go back to the 16th century, or the 17th century, largely, I mean, there was this French philosopher called René Descartes. And he's famous. Even today, we understand, we probably come across one of his famous quotes, which is that, I think, therefore I am. So that quote itself talks about the primacy of the mind in the thinking process. So he is often credited with this idea called mind-body dualism. Mind-body dualism is the idea that mind is a thought process or is a thought center, and body is an implementation vehicle. So you think about something in the mind, and then your body simply executes it, right? So you think that you will maybe go and pluck a mango or something, and then your body goes and does it, right? So he talks about this interesting concept of this mind-body dualism. Today, there are several detractors to this theory of mind-body dualism, but it still holds a lot of sway in the philosophical world, and especially within Western discourse. And that's something that I would like to stress going forward in this talk. So, pardon me? Okay, so that was some disturbance. Yeah, so in the mind-body dualism, through the mind-body dualism or the concept of mind-body dualism, Descartes localized the thinking process to the mind and said that the body is an implementation vehicle, right? So if you're thinking about intelligence, reasoning, and thinking, etc., this is a very interesting way of restricting or localizing the question. So you now only need to look at the mind, which I think in Cartesian terms and Descartes' philosophical terms, it is largely to do with the brain. So you only need to look at the brain to understand where thinking happens, right? So you don't need to look at the body. But today, I mean, if you look at it, body also plays a significant role. So we have reflexes, and there are some cultural norms and so on. And in the Eastern tradition, the mind-body dualism is not a concept that holds a lot of currency. So if you go further, there was this other person called Gottfried Leibniz, who lived during the 1600s, which is the 17th century. So he was well known. Some of you might remember his name through physics, right? Through studying physics in high school and so on. So there was a Leibniz theorem and so on. And he has made some contributions in mathematics. He has made contributions in theology, philosophy, and so on. So he was a polymath in a way. And he believed that human reasoning is possible to do through machines. And there was a very interesting quote that I think illustrates the core of his philosophy. If two people are engaged in an argument, they simply need to go and compute what is the right answer, and then the argument is solved. So two people do not need to break their heads over an argument. They simply need to pick up a pen and paper and compute what the actual answer is. And then that solves it. One of them is right, one of them is wrong, right? So the other one is wrong. And so human reasoning is reduced to computation in a way. I mean, our thinking process is reduced to computation. So we know that some of these things are very don't really look very attractive, right? For example, a lot of our arguments are about opinions. We believe that maybe the government should do things this way, and somebody else believes that the government should do things another way, etc. So these are about opinions. But Leibniz did not recognize the subjectivity of human reasoning in that sense. For him, it is all about computation. And there's this other person, philosopher, again, he is sometimes regarded as the father of political philosophy, Thomas Hobbes, whose thoughts are still mainstream within especially Western political discourse. So he wrote this sentence in one of his masterpiece books, saying that reasoning is nothing but reckoning. And reckoning is about doing small mathematical operations. Reckoning, that is what he meant by reckoning. So doing small mathematical operations or simple mathematical operations and maybe tied together to form a complex structure, but reasoning is eventually reducible to simple mathematical operations. So now what have we got here? Through Descartes, we have localized the process of thinking to the mind, and through Leibniz and Hobbes and several other philosophers, but I can only talk about a few. Through Leibniz and Hobbes, we have now reduced the process of thinking to one of calculations. And this is a very important backdrop that that pervades the political discourse in the West. And it is within that backdrop, it is against that backdrop that Turing asked this question about can machines think. So it is not accidental that somebody in India or somebody in South Asia did not ask this question, can machines think? Because for them, it probably did not make much sense. In the Western political discourse, where there's mind-body dualism and all of these reasoning as reckoning exist, it is much easier to ask this question. Okay, so that's what I want to emphasize here. And here we go to another philosopher, and this person shouldn't be unfamiliar to most of you. He lived in the 19th century, and this is an excerpt from his book called the Grundrisse. And within that, there is a chapter called the Fragment on Machines. And Fragment on Machines is today heralded as something as a prophecy of artificial intelligence, as something that as if Marx had predicted the arrival of artificial intelligence. And this was in 1857. And AI, as we know today, is a concept of the late 20th century. I'll just read through this excerpt and we can try to make sense of it a little bit. So once adopted into the production process of capital, the means of labor passes through different metamorphoses, whose culmination is the automatic system of machinery set in motion by an automaton, a moving power that moves itself. This automaton consisting of numerous mechanical and intellectual organs, so that the workers themselves are cast merely as its conscious linkages. I would like you to maybe think about the delivery boys of our times, right? When the Zomatos and the Swiggies and so on. So what do they do? I mean, even on a rainy day, you will see them attentively looking at their mobile phones, stopping somewhere and with a raincoat and so on. So they're getting instructions from those machines, from the AI algorithms through those machines, and they're just consciously following those instructions. So in a way, the entire decision-making process is done by the AI and delivered to these workers through the mobile phones, and they simply obey these things. So in a way, I mean, I think of the gig economy as something where this quote could be read multiple times with multiple layers and so on and so forth. So we'll come back to some of these ideas, but let me just move on here. So some of you might recognize this person. I mean, most of you would recognize this person. This is Charles Babbage. Charles Babbage lived most of his intellectual work was in the 19th century, 19th century, and he is sometimes credited as the father of computing or father of computer. So he created this interesting model called the analytical engine, which today forms the blueprint of most computers. So there have been observations in the mid 1950s and so on, much after Babbage passed away, saying that today's computer looks very much like an instantiation of the analytical engine that Babbage had proposed. At the time Babbage proposed that thing, there were no computing equipment, so it was just a conceptual model. So Babbage was a computer scientist much ahead of his times. But before computers came in, he was a mathematician in that sense. But he also did a lot of work in other areas. And one of his work was in understanding automation. So he wrote this interesting book on the economy of machines and manufactures in 1832, and a book from which quotes have been used by Marx and responding to other philosophers of his time. So let's just look through this one. And I think it's very important to understand AI within the backdrop of Babbage's understanding of automation. So Babbage, I'll read out this quote. The division of labor suggests the contrivance of tools and machinery to execute its processes. So when each process by which any article is produced is the sole occupation of one individual, his whole attention being devoted to a very limited and simple operation, improvements in the form of his tools or in the mode of using them are much more likely to occur to his mind than if it were distracted by a greater variety of circumstances. So to simplify this, think of somebody working in an assembly line, and an assembly line are these manufacturing processes where you have a conveyor belt and something comes along and you fix a screw or something, and then it goes to the next person, who is downstream. So if you do this process a lot of times, maybe it'll occur to you that maybe you could do this slightly better by using by maybe attaching two spanners and maybe creating a little device, maybe creating a little tool. So by doing this process over and again, there was division of labor, right? I mean, by doing this process over and again several times, it will occur to you how to improve the process. So it's interesting that Babbage makes the statement that the person who does the process is responsible for the technological improvement of the process. So many a time today, when we look at AI technology, for example, we think of ChatGPT as a creation of OpenAI, right? I mean, so when you look back at it, who created ChatGPT and so on? So where does labor lie in that process? So according to Babbage's terms, a particular technology is created by the workers who are engaged in the process before the technology was developed, right? So in that sense, so we look back, we'll come back to this ChatGPT and related questions later on. But I'll just say here that Babbage's thesis that the worker is responsible for the creation of technology is a very profound one in a way. So it does also say implicitly that workers should be the beneficiaries of the technology as well, because they created the technology. But we'll come back to this, and you might have some differences of opinion as well. We can come to those things in questions. So this takes us to the Turing test. So in the Turing test, if you were to create intelligence in the way Babbage talked about intelligence, Babbage talked about automation, then what do? You take one particular process, you do that repeatedly over and over. You understand that process so much so that you're able to conceive about a better way to execute that process, right? So it is by mirroring, it is by creating a copy of that process, but using technology or using tools that you do the thing. So essentially, if you're fixing a gearbox, you would fix it exactly the same way, but you would do it slightly efficiently, because you now have a tool that will help you do that slightly efficiently, right? So the process remains intact, but it is done slightly more efficiently. Whereas when it comes to Turing test, which is the way we understand AI today, it is quite different in multiple ways, but we'll look at one way. So the Turing test and the construction of the Turing test is important to understand before we go into this. So the Turing test says that let us say that somebody, it may be a human or a machine, that sits behind a curtain, and then there is a person who is chatting with that machine or human, chatting with that agent, and chatting by chatting, I mean asking questions and getting responses, asking questions about those responses, and so on and so forth, getting clarifications and so on. And if it is actually a machine behind the curtain, and it is able to convince you that it is actually a human, or it is able to pretend meaningfully that it is a human, then it has satisfied the Turing test. Okay. So when you look at it, it is about generating responses that look like the output of an intelligent process, of an intelligent human process. So it is not about, it is not about mechanizing or automating that same process by which humans generate outputs. It is about simply generating output. So you're not trying to imitate the process. You're trying to imitate the output. Okay. So I hope this distinction is clear. So in Babbage's terms, you need to imitate the process, but do it slightly more efficiently by introducing a tool. Whereas if you're doing something in order to win in the Turing test, what you're doing is you're trying to generate intelligent looking outputs. You don't really require that the machine should think about a topic in the way that a human thinks, but it simply needs to produce outputs which simulate intelligence in a way. Okay, so it is about imitation of outcomes and not imitation of process, and this is the dichotomy that I wanted to drive home in this slide. Okay, so if we go further, in the 1950s, and this is more of a historical introduction to AI. In the mid 1950s, after Turing's passing, there were a few mathematicians in the East Coast of US largely who convened a 2-month workshop. So we proposed that the 2-month, 10-man study of artificial intelligence be carried out during the summer of 1956 at Dartmouth College in Hanover, New Hampshire. Okay, so these 3 people and also one other person got together and made up a proposal in order to the Rockefeller Foundation, and interestingly to the Biological Sciences Division of the Rockefeller Foundation. So this is where you see the blurring of lines between automation and intelligence. Turing published his paper in Mind. Okay, that is in the cognitive sciences, and these people were getting funding from the Biological Sciences Division of the Rockefeller Foundation. So they were successful in procuring funding, and they did this workshop, and this workshop is largely branded today as the founding workshop or the founding event of artificial intelligence. And they were largely driven by the Turing test, or by the ethos of the Turing test, although they did not really admit that in the writings of the time. So once again, the imitation game that we described last, the Turing test that I described in the previous slide was actually called as the imitation game by Turing. And Turing's imitation game was to test whether there is a pretense of intelligence. So he was not using that as an answer to the question about can machines think. He dropped that question and asked a different question. And somehow today, I think we think of the Turing test as the gold standard way of checking whether a machine can think. That was not something that Turing intended. And I say this because in the computing world, Turing holds such a clout. So saying that Turing was wrong is not very fashionable. But here I'm not even saying that. I'm saying that Turing did not intend to create the Turing test as a test of intelligence. But we, the community, the AI community, and I'm talking self-critically as being a part of the AI community here, the AI community branded the Turing test as a test of intelligence, which was not something that Turing intended. So John McCarthy was an interesting character. So he, he wrote a paper in the 1980s, and that's something that is useful to mention here. he believed that thermostats have beliefs. Okay, so let's take the simple example. So if you take a simple thermometer, does it have intelligence? And that might be a very absurd question, because a thermometer cannot have any intelligence, right? It just senses the temperature and shows you the temperature that there is the ambient temperature at that time, right? In that place. But when you connect this thermometer to an if-else clause, if you think about it in programming terms, and make it a thermostat, which basically means that if the thermometer reading goes past a threshold, then you switch on the cooler, or if the thermometer reading goes below a threshold, then you switch on the heater or whatever it is, right? So that kind of a thing. So that is what a thermostat does, and thermostats are all around us, right? Because the fridge has a thermostat, and the ovens have thermostats, and even your kettle, right? Electric kettle has thermostats. Thermostats are all over us, all around us in day-to-day life. And John McCarthy, interestingly, believed that thermostats have beliefs. So he said that a thermostat has a belief as to what the temperature of the room should be. Is it normal, or is it too hot, or is it or is it too low? So this is a kind of anthropomorphization, thinking about a technology as human, that pervaded his thought. And he has written about these kinds of mechanisms quite a bit. And everywhere in John McCarthy's writings on these kinds of topics, it becomes clear that he was thinking about these machines as if they were humans. He was anthropomorphizing them. And today we are at the extreme end of anthropomorphism, in the sense that we think of ChatGPT as a human, right? In a meeting, I mean, if you find it hard to think, answer a question, we'll say we'll ask ChatGPT as if it were a human, right? But it is a technology which doesn't have a mind of its own or anything. It could be different. It could give out a different answer to different people at different times and so on. So, so in 1956, they developed this. They did this workshop, which was considered as the founding event of AI. And the question here was, how do you create a pretense of intelligence? I'm using the word pretense, although I mean I did not mean it in a derogatory sense or in a sarcastic sense or a cynical sense or anything of that kind. What do you do in order to win the Turing test, right? That is a whole idea here. And there was this person called Joseph Weissenbaum who created this interesting tool called ELISA. And it is regarded as the first chatbot. And in today's ChatGPT world, ELISA is being brought up in philosophical discussions even more often than it was over the course of his lifetime. So what is ELISA? ELISA is what is called as a Rogerian psychotherapist. The discipline of Rogerian psychotherapy, the little that I know about psychotherapy, I'm talking through that, but is about putting the onus on the patient. So, so if you say that, oh, I've been very unhappy, and then the Rogerian psychotherapist will ask you, what makes you unhappy? And maybe you will say that some incident, and then they will ask you, why did that incident make you unhappy? So this is about putting the question back to you. So it's quite simple to automate in a way, and that is what Joseph Weissenbaum did. And so he created these interesting rules. For example, if somebody says that I am feeling X, it will simply ask, how long have you been feeling X? And X could be depressed, X could be anxious, X could be tensed, X could be something else as well, right? So, or even happy for that matter. So it could even work in scenarios outside psychotherapy, in the sense like a general chatbot. So when you create complex enough rules, Joseph Weissenbaum found that people tend to think of the output of those rules as intelligent behavior. So he has this, there is an interesting anecdote from Joseph Weissenbaum. He says that his office assistant used to turn the computer to one side before chatting with Elisa because she did not want him to see the conversation. So it is almost like she was ascribing agency to Elisa and thinking of Elisa as a human. And there is privacy between humans, right? So essentially, she was thinking of it that way. And Joseph Weissenbaum later became a very severe critic of AI, and he wrote a book in the 1970s saying decrying AI to as it existed then. So we'll come. I mean, there are those kinds of resonances of those arguments coming again. So, so there are two ways of creating a pretense of intelligence. One is like John McCarthy did, like use a sense and respond mechanism, like thermostats. And today's smart homes, for example, are a bunch of these sense respond mechanisms. One of them will sense whether the room whether the room is too moist or whatever it is, right? Too moist, too hot, too airy, whatever it is, and then do something in order to address that. So, and the Internet of Things are all about sensors and little pieces of intelligence embedded within those sensors. And when you orchestrate them, it almost looks like it is a being, right? So there was a recent Malayalam movie that I don't quite remember where there were a bunch of these lights, and when somebody goes next to that house, things light up in random ways, and it creates a frightening experience, and it almost feels like there's somebody there, some ghost there in that particular movie. That was the context. So, but if you have a lot of these sensing mechanisms, and then feeding into a little logic which responds to various kinds of sensing, then you can create an illusion of intelligence, and that is something that is potentially maybe related to the primacy of senses in our daily life, right? I mean, we understand things by touching them, by hearing about them, by reading them, and so on and so forth. So that is one way of creating a pretense of intelligence. And the second way was using, like Joseph Weissenbaum did, by creating complex rule sets which create this behavior which looks like intelligence, like in the case of this psychotherapist. But these two mechanisms can only go so far. And in 1980s, there was this person called Hans Moravec. He said that it is comparatively easy to make computers exhibit adult level performance on intelligence tests or playing checkers, and difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. And this is a code that has been interpreted in a variety of ways. There was a mathematician called Polanyi. I hope I'm pronouncing it right. So he talks about tacit knowledge. So think of how you can describe riding a cycle to somebody. How do you ride a cycle? You cannot describe it, right? I mean, you can only show it. And even when you teach somebody to ride a cycle, you cannot tell them that you should do this in this particular instant. You give them a goal, which is to remain balanced, not fall off, and they will figure it out by practice, right? So certain things come by practice. So Polanyi said that we know more than what we can say. So that is sometimes referred to as tacit knowledge. We know a lot of things, but we can only say some of those things. We cannot represent some of these things. And Hans Moravec was also saying something on those lines. So you're saying that perception and mobility are things that a young kid can do. Tasks related to perception and mobility are something that a young kid can do with very effortlessly, but an AI cannot do that at all. So how do you do this? And this wasn't solved by sensors, or this wasn't solved by complex rule sets. So how do you go about doing this? And that is the context in which this data-driven modeling comes into play. So one of these data-driven mechanisms that is used within AI is called as neural networks, which is something that you might be familiar with. And neural networks was very hot in the 1980s or so on, and then it went into oblivion a little bit, and it came back up in the 2010s and so on. So neural networks are about creating these decentralized little decision processes, which are all decentralized, and it is modeled upon this neuron, or the human neuron. And I would say that it is a very reductive modeling of the neuron. A human neuron does a lot more than what a computational neuron does. A computational neuron, as you can see in the bottom, it takes a number of inputs. It doesn't aggregate. It potentially uses a threshold function, which is an activation function, and then creates an output. But a human neuron probably does a lot more things than that. But essentially, it follows the blueprint of a neuron to some extent. And what does this do, right? So we'll come to a little bit of that, but just very quickly about the internals of neural networks. It uses a technology called backpropagation, which was proposed in the 1970s. And in the 1970s, when they proposed it, there wasn't enough data. And it was when data became very large, and there were plenty of digitization happening in the 1990s, that this data-driven paradigm of machine learning really took off. And what is this data-driven paradigm? So you are unable to create expand into tasks relating to perception and mobility by using this complex rule sets or the sensor driven operation model. So what do? You simply take digital traces of what humans have done, and then reproduce those digital traces. And by reproduce, you might disagree a little bit, but it is not just about simply reproducing it. It's about taking these large data sets and finding patterns within them and putting these patterns together in newer ways. So it's not a regurgitation of data in a very shallow sense, but it does a little bit more than that. But eventually, it is about it is largely driven by the data, that you give it to it. So, if you have, so what does ChatGPT do? ChatGPT is driven by, is based on billions of documents actually on the web. So, if you were a blogger in the 2000s, your blog post, which you have long forgotten, is probably still powering ChatGPT to an extent. Everything on the web is within the ChatGPT's corpus, and there are even people who claim that, with sufficient reason, that there are copyrighted material that are also used to train ChatGPT. So ChatGPT uses this massive corpus and mines patterns out of it. And it uses these patterns and puts these patterns together in interesting ways in a query-driven fashion. So if you ask it about a topic, it'll take patterns that are related to that topic, mash it up, and present it to you. So that is the data-driven paradigm. So here you don't need to know the process at all. So this in some way follows the ethos of Turing test in the sense of the imitation of outputs. So in the complex rule sets world, you still knew what was happening, but the rule sets could get very complex. So they tend to become opaque because you cannot look through hundreds of pages of rules. It can become opaque in that sense, but you still had control over what was happening. But here it is all driven by data. So here in this world of machine learning and data-driven AI, you have two kinds of processes that determine what decisions it will make. One is the process. One is the algorithm design process, which is to say, how do you put together these patterns, or what kind of patterns do you discover? And the second one is actually the data set itself, which is authored by hundreds of people. So if you find the ChatGPT is problematic or delivering a problematic response, the OpenAI engineer or OpenAI will tell you that it is not our problem. It's a problem with the data that is available on the web, right? So in that sense, they can shrug off responsibility in a way. So it's interesting in the sense that it creates an imitation of outcomes. It allows the person to kind of delegate the responsibility to other people who created these outcomes in the first place, which is data creators, which are people like us. So despite all of these things, Deep Blue in 1997 had huge success in defeating the then Grandmaster. So this is a classical example of how far transparent AI could go, or it is sometimes called as good old-fashioned AI, GOFAI. So this Deep Blue was powered by rule sets, like the Rogerian psychotherapist that Joseph Eisenbaum created. And that could defeat a chess grandmaster. But it could defeat the chess grandmaster because the rules of the game of chess was finite, right? I mean, it's a very controlled environment. Things don't happen randomly. It's not like if you're driving on the road, things happen which you cannot specify, right? I mean, there could be something, there could be an animal walking on the road, there could be the car could go wrong in 100 different ways, and so on and so forth. So, but this is a very complex game, but it is still very closed world in the sense that you can specify it by using a handful of rules. And within this kind of a thing, Deep Blue and other AI systems could do very well. So the AI, when you look at it, when you look at it today, can be thought of as the search for an ultimate induction machine. There are two ways of knowledge creation, if one could think of it that way. One is deductive reasoning. So if you think of an example to illustrate deductive reasoning is that, let's say that the lawn is wet, and you have a rule saying that if it rains, then the lawn gets wet. Then you can say that, if the lawn is wet, then there is a probability that maybe well, actually, that is not a very good example, but essentially, I'll go to the more classical example. All men are mortal, and Socrates is a man. So these are two statements. And based on these two statements, you can say that Socrates is mortal, right? Because it deduces, it follows from those two statements that Socrates is mortal. And that is deductive reasoning. And that is what most of our high school math and so on did. But inductive reasoning is about making generalizations out of observations. So let us say that you found maybe hundreds of sheep and they're all white. Maybe you'll make an assumption that all sheep are white, but that may not be true. So unlike deductive reasoning, inductive reasoning need not be true all the time. It can fail with a small probability. And AI is today based on generalizing from data. And in that sense, it is about inductive reasoning. So if you look at the AI landscape, I'm using this viewpoint from this book called The Master Algorithm by Pedro Domingos, a University of Washington professor. So he talks about 5 kinds of AI. One is the symbolist, which is like the Rogerian psychotherapist, right? The Weizenbaum's Elisa chatbot and so on. So it uses symbols. I feel X, and you ask how long have you been feeling X, and so on and so forth. And then there are these connectionists, which is the neural network and related stuff, where you have a big bunch of weights and you cannot make sense of it. And then there is evolutionary AI. Then there is Bayesian AI, which is basically the application of the Bayes theorem. And then there are analogizers as well. So I won't go into these kinds of details. Symbolists and connectionists largely capture the large bunch of AI systems that we have today. So machine learning is today's AI, and let's just briefly illustrate machine learning. I'll just use. I know that I'm slightly getting to time, but I'll just go through this example very quickly. You have these kinds of data sets, which is an input and an output. You have an input image, and the output here is the first image is the number 3. So your output is a number 3, and the second image is that of somebody handwritten digit 2, and your output is 2. And you create what is called as a statistical model. And the statistical model could include a number of possibilities, but here I'll illustrate a very simple statistical model, which is a pixel, a 50 by 50 pixel grid, let's say, and all images are also 50 by 50 pixels. And here you might have a little statistic that captures the pattern in the data set. Among 40 images where this point is white, 35 were tagged as 3. So if you get a new image where the central pixel is tagged as white, you have a high chance that you label it as 3. And you could have a number of other statistics, and you use the statistical model in order to make inferences. So you have a new image and you gather a number of these statistics. So this particular pixel is black. So you capture what is the probability of the digit being 1, given that that pixel is black, and so on and so forth. And you capture a number of probabilities, and then you aggregate it in order to come to a decision. And this is an application of the naive Bayes formulation, not quite the complete application, but it's along those lines. But I just want to illustrate this. And neural networks are much more complex. They use a number of weights and so on. So you have hidden layer, input layer, output layer, and a number of weights between these neurons. And each one of them is like a neuron. So I'll just briefly go through. Okay, so I'll just skip this slide. I'll just briefly go through some of the implicit assumptions that go into today's AI. One is that history repeats itself, right? Or that historical patterns are useful to make decisions for the future. And many a time within the AI community, this is generally regarded as a truism, in the sense that it always happens so. But does it happen so in all domains? And that is a question that we should be asking, because if we look at grocery store purchases in a grocery store, it might be reasonably true. If you bought milk and bread last week, you're probably likely to buy milk and bread the next week that you come along. But when you look at maybe crime prediction, is this true, right? So let us say that crime prediction and usage of crime prediction in policing systems is a very dynamic, yields a very dynamic system. So if you use crime prediction and say that certain regions of the city are marked as red, which means that there is more crime likely to happen, and you put more police there, the criminals will get a sense of what is happening, right? They won't go and do the same kind of operations in those same locations, because they now know that there is more police there. So they will go into another location. And the same happens in the case of maybe antivirus systems and so on and so forth. So whenever you develop an efficient counter measure, people will act around it. People will find ways around it. And that is why maybe ML or machine learning is generally regarded as probably unlikely to be heavily effective within, like, say, stock market prediction. So if there is a very interesting stock market prediction algorithm which says that the stock price of this particular company is going to go up, and everybody believes in it, everybody believes in the AI system, everybody will go and buy that, and it will go much more higher than what the AI system predicted. So if you're working in these dynamic systems, the notion of historical patterns recurring is not necessarily something that you can take for granted. And then there is this notion, there is this thing about data distribution and fairness. And this is something which relates to where AI is created. So AI today, I mean, if you use an image recognition algorithm or a face recognition algorithm, that is probably built by somebody sitting in the Bay Area, somebody sitting in a company in the Bay Area. And the Bay Area ecosystem has a particular demographic, right? I mean, it is largely white. It's maybe not necessarily fully white, but essentially educated people, rich people, and so on and so forth, or industrious. And so there is an interesting acronym called WEIRD, WEIRD, white, educated, industrious, rich, and democratic, and so on and so forth. So and when they source data sets from their own networks, they might, I mean, the Bay Area tech ecosystem is largely male. So you would create data sets that are largely male as well. If you source it using those networks, and that yields these kinds of accuracies. For example, Microsoft face recognition has almost an 8% error rate difference between males and females, and certain other companies have much more higher difference in error rates and so on. So I mean, these might look a little small, but I mean 89 and 97, maybe you'd think that it is okay. But if you think of it in another way, if you fail at the face recognition system, then you are redirected maybe to a security, to a manual security process. And if you look at the queues at the security process, and which is basically because of errors from this face recognition system, you'll find that there are 5 times more females than there are males, right? Because there are 2% errors for males and 10% errors for females. And so it creates, I mean, 90 and 98 may not look very different, but 5:1 is a very different thing, right? So the way these are used also yield interesting levels of unfairness and so on. So, and this is a point I think which I'll make, and then I'll start winding up, which is essentially the point that if you use these kinds of mathematical modeling tools, you're probably going to create anti-minority behavior. And there's a little nuance to it, but I'll try and explain it. So most of the models today are what are called as parametric models, which means that they have a fixed capacity. So let us say that there are 2 kinds of population there are 2 kinds of demographics in the population. One is, like, let's say, majority demographic, and another one is a minority demographic. And both of them have 5 distinct patterns of operation. And let us say that you cannot quantify different patterns and so on, but let's assume for the moment. And let us say that you're building an AI tool, and the AI tool can only hold 6 patterns. So how would you decide what to store? If you are concerned about being inclusive and so on, you might take 3 patterns from the majority demographic and 3 patterns from the minority demographic. But if you are interested in making as many good decisions as possible, which is the philosophical theory of utilitarianism, the more as much good for as many people as possible, then you will implicitly take in more of these majority demographic patterns, because you are interested in making more decisions right, getting more decisions right, and the majority is more abundant. So if you cater better to the majority population, then you will get more decisions right. So there is an internalization of anti-minority behavior, or internalization of majoritarianism within this kind of a thing. And today people talk about model collapse, which is about training over generated data and so on and so forth. So you get the mainstream patterns and create a chatbot, and that chatbot reproduces those mainstream patterns and use that in training. The mainstream patterns become more and more mainstream, and it leads to what is called as model collapse. Model collapse is an interesting and emerging area. You might want to look it up if you're interested in. So there are simple models could also lead to very interesting forms of bias. Let's say that there is a class of so many students, of 7 students, and this is their marks. And if you take the average, you get an average of 64.28. But let's say that you look at the gender makeup, right? And and this is largely, like our STEM subjects, we have mostly male and a minority of females. And if you look at the male and female averages, you would find that there is a significant gap. So if you simply take the average, you're already privileging the majority. And there's an interesting history of the philosophy of the usage of mean and averages within historical context, and that's a different topic which we'll not get into. But even using simple forms of mathematical processing could lead to privileging, could lead to maybe a majoritarian ethos. And I'll just skip this. So, and bias training data is another issue. And some considerations that might come up from some of the topics that I covered in this talk is whether imitation of outcomes is acceptable in all kinds of settings. For example, let's say that you're taking an X-ray and you give it to an AI and it gives you a diagnosis, but it cannot tell you how it produced a diagnosis, or it cannot, even if it tells you how it produced a diagnosis using explainable AI and so on and so forth, it might still not be following the logics of a trained, experienced medical practitioner. Is it still okay to use it in those? and is fundamentally a data first approach, which is what AI is. How does it sit with the considerations of inclusiveness? And this touches upon the majoritarianism that I was mentioning towards the end. And how does the absence of theory work in complex situations? And today, in the last, not today, in the last decade or so, when you look at these two factors, one is algorithm design, one is data. Data has started getting more and more dominant in determining the decisions of AI. And so the algorithm design, which encompasses the theory of how to make decisions, is becoming more and more marginalized because you're getting more and more data. That's why OpenAI is a monopoly in the space, and this why these big companies have become monopolies within AI within their own sectors, because data has become much more prevalent, and data can be gathered very effectively within these corporate environments and so on. So I'll just briefly introduce some of these books very quickly. I mean, there's this interesting book. I use some of the concepts from the reading of these books within the talk. One of them is Resisting AI, an anti-fascist approach to artificial intelligence. And this Eye of the Master, which is a book that came out late in 2023, is a very interesting exposition of the social history of artificial intelligence. And Inhuman Power is another reading of artificial intelligence and its connections with capitalism. And I'll briefly take one more slide to introduce two books that I have been involved with, and these are in Malayalam. One is Chindikkunna Yantram, which was recently brought out in 1 month back by Chinta, and another one is from DC Books that I published last year. So that's it. I'm now open for any questions or comments, and I'll stop the sharing of the screen so that I can see all of you. I suppose it's okay to type in any comments as well. I'm sure that many of you would not have agreed to some of the opinions that I used in my presentation. So feel free to, I think I'm happy to listen and comment on any interesting disagreements that you might have as well.
So Deepak, there's a question in the comment box. I think you're mute.
Okay, that's well, that's interesting. Thanks, Gopakumar, for the question. So what are the research opportunities in AI and robotics and automation? So, I mean, AI is being used in several fields. It is clearly being used across a vast number of fields, and especially, I mean, even today, right? I mean, you hear about AI all the time. So I think I'm not an expert in robotics, and I think by automation you mean business process automation, robotic process automation, etc. Not an expert in those kinds of things, but whenever there is an abundance of data, I think that's an area where AI could play a role. And in some of the areas, for example, when you talk about enterprise applications and so on, the data is often not public. But there are several other kinds of areas where data might be more available, and not necessarily publicly, but through maybe some non-disclosure agreements, etc. for your research if you are working in an academic institution. There are plenty. So maybe well, it's a blunt answer, but I would say that if you were to look for areas, I think in a short-term perspective, I think areas where there is accessibility to a lot of very rich and heterogeneous kind of data, and that might be an interesting way. I'm interpreting this question as largely relating to maybe a potential PhD student, etc. So I'm not sure whether Gopakumar, what your position is, but if that is from that perspective, I think looking at areas where there have been where there is a lot of where there is a larger data footprint might be useful. So, and I think there is a question later, Jacob Thomas. So, how do they do computation to settle an argument in the 18s? Okay. So I think it relates to the mention of Leibniz's philosophy, which is to say that if two people are engaged in an argument, they just pick up a pen and paper and solve what to do. But that is evidently not the way that people solved arguments in the 18th century, right? I mean, we have 18th century. I mean, there were various battles and so on all across history. I don't know particularly about the 18th century, but I think so I was pointing out a particular philosophical take on arguments between people. I was not making a generalized comment on how.
What is the aim in this?
Sorry, Babu, you
sir, yes, sir. I have a question, sir.
Yeah, sure.
Good evening, sir.
Yes, sir.
Good
evening. Yeah.
Sir, my question is that, sir, how does artificial intelligence make the sense of credibility with regard to image processing, sir, in your perspective?
Can you say the question again? Artificial intelligence and credibility.
Sir, yeah, sir. How does artificial AI make the sense of credibility with regard to image processing, sir? Image processing.
Okay. Yeah, so within image processing, it is about finding data, and in a particular sense, there is this neural network building block called convolutional neural networks, which are heavily used within image processing. So I mean, I'm not sure at what level I can answer your question, but one way to say this is that if you're looking within image processing techniques, you look at localized patterns and try and put them together to make inferences. So that's how an image prediction algorithm can identify a cat, whether the cat is in the top left corner or in the bottom right corner or in the center of the picture. So largely it is about identifying localized patterns and then making inferences out of it. And there are some people who think that is the way human processes look at images, in the sense that you first identify at a very low level, which we probably don't do. We look at the pixels, and at a higher level, we look at the edges or the boundaries, and then at an even higher level, we look at your shapes, and at an even higher level, we look at the interactions between shapes. And people have said that if you use deep neural networks, at the lower level, it is largely focused on finding boundaries, and at the higher level, it is largely focused on finding shapes and so on. So an argumentation about the credibility of neural networks for image recognition rests on that similarity between the logics of the human processing, which goes from pixels to boundaries to shapes to interactions, and it's mimicking within the deep neural networks place.
Thank you, sir. Thank you so much, sir.
So I think the few more questions now. So let me just quickly address them. So as much as I can, of course. So how can machine learning be leveraged to improve poverty prediction in a country like India, ensuring that welfare schemes are provided to those who are in actual need? So there has been a lot of work in that space about taking data and trying to make things more efficient and so on and so forth. So in terms of like distributing funds and making sure that the most needy get those funds and so on and so forth. But I think I mean, one way to look at it is when you look at poverty is an extremely complex thing, right? Poverty is very localized in certain places. It's also related to other kinds of demographic things. It's related to maybe casteism, sexism, and so on and so forth, and a lot of things. So you could potentially develop an AI model in order to do some efficient targeting of welfare schemes. But I would say that it is not quite a replacement for human due diligence. So I think one way to look at it is how can you meaningfully take the nuances of the domain and the human due diligence within that and bring that into poverty or other kinds of things. So simply saying that maybe there is AI, there is data, let's use it for this thing, is not quite doing justice to the domain itself. So, and the next question is about how XAI achieves interpretability and accuracy trade-off. Explainable AI is a different topic in itself. I could do a separate thing. I teach explainable AI, and explainable AI is used. I mean, is not necessarily faithful to the actual decision making. So today's explainable AI is largely what is called as post hoc explainability, which means that the decision making model makes a decision, and you try and explain that decision not by using the logics of the decision making model, but by using something else, by treating explainability as a separate problem. But so if you look at intrinsically explainable AI methods, they probably don't fare as well in terms of accuracy, and that's something that is a problem. So there is an interpretability accuracy trade-off, which is still potent enough to maybe create a lot of PhD. So if you're looking potentially at maybe guiding students or something in that area, I would think that that's a very fertile area. So I'll go quickly again to VT Gopakumar's question. Another question. So in the present world order, in which direction AI converges if you forecast year 2030 to 2035? I mean, it's always difficult to make predictions, and somebody said it is always difficult to make predictions, especially about the future. So so I think I mean it won't be quite right to say something, but say things for certain. But one potential direction, which I think of as very important, is that current AI models are very data hungry. They need lots and lots of data in order to make sure that they can work well. And if it ends up doing this, right? I mean, and if you want to build the next generation of AI models, you need even more data. But already a lot of the data is being roped into AI models. So we probably enter into a new different paradigm of data scarcity and how AI can operate within the data scarcity situation. So maybe data, making good use of available data for specialized circumstances, for example, where large data sets are not available, and that could be something that could be very interesting to look at. I mean, so I would say that instead of big data and big data and that kind of AI, I think AI with little data is also an interesting thing. And we don't know how the world will address the data scarcity issue. Which is kind of ironical. We talk about data everywhere, but I think the AI models have gobbled up all the data that is available. So with that, I'll go to the next question. So this is out of context for today's session, but can I ask a question regarding AI agents? What is the framework of these AI agents, and also regarding framework of multi-agents? So multi-agent systems are a very important research direction, and the combination of multi-agent systems and reinforcement learning is a very interesting direction as well. So and I think I've not looked so much at AI agents as much. I've looked at some parts of it, but as I said earlier, I generally tend to take a critical perspective of it. And when you look at AI agents, I think it's interesting to look at how these decentralized mechanisms of operation come together. How do they collaborate, and how do they make decisions? And that's interesting to analyze from a political perspective as well. So that's something that I might want to do in the next year and a year or two, and then maybe after that I would probably have a better answer for you, Karthik. So I think Babu is asking me for the email ID. I'll just type that. And Nishada's question is AI used to improve cybersecurity, and that's a very, very interesting thing. And as I mentioned there, AI is a tricky fit with cybersecurity, because cybersecurity has malicious actors, right? So so if you say that you will look at previous patterns of operation and then make use of those previous data sets in order to produce new kinds of behaviors with an AI, that may not work well for cybersecurity, because of the cyber attackers find that you are good at attacking a particular at maybe safeguarding a particular kind of security, then maybe they might resort to other forms of getting into the system, or intruding into the system. So cybersecurity is a very dynamic domain, and it's interesting to see how AI could be very effective within solving that, and how some paradigms of AI, such as like I mentioned, stylistically, as history repeats itself, how can it be relaxed in cybersecurity? That could be a very interesting paradigm to look at. So
Sony Thomas here. So, sir, I had much like a three-part question, if you had the time. So,
sure.
sir, firstly, usually when we start out in college, our teachers ask us to study more, like everyone asks us to study data structures and algorithm in order to get into a very good computer science field. I mean, get into a good job in computer science field. But then when you start out in machine learning, it's kind of confusing as to the number of algorithms that you have to learn, and that these algorithms are mostly math based and that they're mathematical models. So if you were starting out today, what would be your ideal starting point, or like an entry point? What would be your plan on tackling this, trying to get into the space, trying to learn how to create ML models?
Okay. So one thing that I might offer as maybe a comment is that so many a time today's ML models and today's learning of ML models is largely driven by get things done. If you think of it as a philosophy, right? So today you have this 1-day courses in order to master image generation, for example, right? You will master image generation by using a tool, but you would also be tied to the tool. You won't understand the internals of it. So what I would say is that as a student, or as somebody coming into a particular field, I would say that you understand the underpinning logics of the field, in the sense like how do these things work? How does ChatGPT generate its responses? Can you understand it enough to explain to a maybe a 7-year-old, and then later on understand enough to explain to maybe a young adult, and then understand enough to maybe implement a small version of it yourself by using maybe 50 documents that you have gathered and so on. So I would say progressing in that sense of demystifying AI and understanding AI from the bare bones would be a much better approach than sometimes what is used today, which is like maybe a get things done approach, which is to take a tool and understand how to feed images into it. By that way, you are only understanding the tool. You don't understand what is going on. So you'd become much more tied down to the tool than being empowered. You become enslaved than being empowered. So I would say go and pick up from the bare bones, and then work from that. I don't know how much of an answer it was to your question, but I hope that perspective is useful to some extent.
So, sir, I'm just trying to grasp what you've said here. So you mentioned that we have to understand how a particular model or like a particular application of a model works, and that you can start from there. But then right now I have kind of like, this is like a personal question. So like I have kind of a basic understanding of how different models work, like how the generative pre-trained transformer works, or like how Gemini works, how the BERT works. But then it's not possible for me to use like a personal machine and then replicate the same and to replicate the entire model or replicate the entire process, because it takes a lot of intensive resources. So then, but at the same time, when you look out for opportunities, research opportunities in the same field, they ask you whether you have experience working in GPTs, whether you have experience working in the NLP sector. And you can't really say that you have experience. You know the theory, you can't really say you have the experience because you don't have the resources. So it's like a conundrum there. I mean, it's something that I don't know how to tackle.
Yeah, I know what you're saying. So when you're looking particularly maybe for jobs, they want to see how less training can they offer you and still make you productive, right? That's so that's how they look at it, rather than looking at how well you understand it foundationally. So I think well, in general, when this goes back to what is the purpose of education itself, right? I mean, the sense of Do you want to do you view education as a way of opening your eyes, or broadening your viewpoint, etc.? And if that is the case, then I think it's important to understand technologies from a very fundamental perspective. It might take much longer, and I understand your point, in the sense, like, in this very fast world, time is very precious, and you may not have that kind of time. But I think one way to look at it is maybe doing one of these Coursera courses on AI might be a good start, rather than going into one of those get it done, like dummies, that kind of stuff. So I know I'm not offering you a very instructive answer, but I think your question also relates to some parts of the job market, which I am I'm as worried about the next generation, that they're being stressed out through this fast-paced job market in AI. And I don't see that as a desirable situation at all. But I think, as they say, these times will also pass in some way. But I think I know I'm not
Yes.
of great use there, but I hope you understand the rationale behind what I'm saying.
Perfectly, sir. Perfectly. Thank you so much.
Sir, I'm Amritesh here.
Yeah,
So
hi.
I would actually like to add something in the previous question that Sony asked. So he actually asked that, like, in order to implement like pre-trained transform models and all, it's like huge resource intensive task and all, right? So that's actually what he's referring, I guess, it's actually to generate something like huge text or huge sentences. So what we can do, in my opinion, is that if we have like 3 or 4, like 1,000 pages textbook, and if we have a decent amount of, graphic card and stuff like that, and decent amount of hardware, we could actually build something really similar, but not exactly that, but really similar to that. For example, like generating the next word, next word or next letter. So that is like less more work intensive, but actually does the same mechanism. But only thing is that it lacks data, such that it won't be able to predict the entire sentence, or just like in other pre-trained transform models. So the implementation is safe and secure there, but the working is kind of different, because the resource we have is less, but the logic and all would stay same, right?
Yeah. That's kind of what I was indicating also at some point. So your toy models that you built using maybe 50 documents may not work as would definitely not work as well as ChatGPT or something. But that is not. mm, Uh, but when you look at building that thing as a learning exercise, you're not trying to beat ChatGPT anyway, right? In the sense, that they have a lot of data. So this is about maybe you build this little language model by using this 50 documents, and then you look through the errors that it makes, right? Or maybe the outputs, and see whether why does this not make sense? Why did it come up with this output? And maybe you'll think about it by saying that maybe it's because you should look at more longer range patterns, and then maybe you would go back and add an attention layer to it. And then maybe you'll get a different kind of error. And looking at that error, maybe you'll find that maybe you should do things slightly differently. Maybe you should get rid of some part of the network, etc. Maybe you should whatever it is, right? So essentially, being starting small has this advantage of being manageable and being able to iterate, right? In the sense of looking back at the data, and then if you make a small change in ChatGPT, which works over billions of documents, you don't know what is going on. But in these little toy documents, you get a sense of what is happening. And if I remember, if I can recollect one point, there was this statistical language models that were once popular in the 1990s and also in the 2000s. And when I used to give some lectures about statistical models, what I used to do is I take 3 sample documents and build the entire metrics and show why some of these entries make sense, some of these entries do not make sense, etc. And see and trace the entire thing, make it entirely transparent, And so implement the statistical language model within an Excel sheet, for example. In an Excel sheet, it's fairly simple, right? I mean, you have a bunch of formulas and so on, and give yourself these little interesting tasks, right? So maybe implementing a little LSTM on an Excel sheet, it's doable in a way. You could potentially challenge yourself in that sense, and that might improve your learning in ways that peddling with a TensorFlow will not do in maybe 5 days. And so I think starting small and iteratively understanding things is very important, and being critical about it is very important as well. So I'm largely in agreement to you, Amritesh, what you're saying.
Thank you so much, sir. Sir, I have one more question. It's actually an opinion which I'm asking you. So, what is your thoughts on the influence of philosophy and psychology on artificial intelligence further along the road? Like how, because you, as you mentioned, you said like we have huge amount of data which is like interfering with algorithms and patterns. So, what is your opinion on the like psychology and the
Yeah, I think it's indeed extremely important, is what I would say. And one part of my one part of the point that I want to drive home in this talk is that today's AI is largely driven by the philosophical backdrop of the Western world. And so if you look at the Eastern world, and there are plenty of philosophies in the Eastern world, right? So I mean, for example, there are spiritual philosophies, there is Taoism, there are all sorts of things. And if you look at it, and if you think about intelligence, what is it? If you look at the question of intelligence from those kinds of perspectives, you might end up building a very different kind of AI. So I think, I mean, it's extremely important to bring in philosophical and political perspectives into AI, and that is something that we don't quite do much. I mean, in the sense, when we talk about let's say reducing crime, right? We always maybe talk about getting some data and training something and using AI in order to identify potential criminals and so on and so forth. And so what are the values that we bring into the place, right? So if you do that, if you do it this way, where does the AI sit? So there is this jurisprudence philosophy that you are not guilty. Sorry, you are innocent until proven guilty. So here we are already making a prejudgment about a particular person, and that person is likely to make a crime, right? So commit a crime, and that is what predictive policing does, right? So there is a I mean, so implicitly the values and the political philosophies all go into the AI making, even if you don't think it doesn't. It still does, because if you're building a predictive policing application using AI, then that is what you're doing. And if you're building maybe a poverty, a welfare scheme targeting app using AI, then you're also doing that to some extent, right? Because you're saying that some people are ineligible, and that ineligibility for a particular welfare scheme can be a decision that can be made by AI solely, right? I mean, there is a value statement. That is a political statement as well. So I think everywhere in the application of AI, it is intensely political. Especially, you're no longer doing this handwriting recognition only. You're making judgments about people. You're making judgments about institutional structures. You are making judgments about who should go to jail. I mean, for example, in the usage of law, in usage of AI within judiciary in the US, for example. So I think the importance of philosophy, politics, and also cognition, psychology, that's not an area that I'm extremely familiar with, but all of these things are going to increase and going forward. And that, I mean, we're already seeing some parts of it, right? For example, there is a much stricter regulation on AI coming from Europe and so on, and that doesn't go far enough. I mean, so people are deliberating about how do you improve it, or how do you increase it, and so on and so forth, and how does it tie to the economic model that we have today, and so on. So all of these interdisciplinary questions will come back up, and I'll finish the answer to that question with a little example. So in most of the philosophers that I mentioned in my slides, were people who are multidisciplinary philosophers, if you think of it that way. For example, as I mentioned, Leibniz was a mathematician, was a theologist, was a philosopher, was a physicist, and so on and so forth. So when we learn, when we learn about something today, in today's world, we learn more and more about less and less, if you think of it that way. Whereas in the olden world, people used to learn more and more about more and more. And the more and more you learn about more and more, I think it is an intensely liberatory thing. I mean, so I would think that you would feel empowered. So rather than putting yourself, as students, rather than putting yourself in a very small disciplinary sub area and understanding all the nitty-gritty details of that sub area, I would say that you should broaden it up and then understand what are the institutions that are affected, what are the people that are affected, what are the what are the normative principles that operate within that area, and so on. So if you look at it that way, I mean, it's an extremely liberatory way to take that approach. And I would think that within that approach, philosophy, politics, psychology, cognition, and everything would play a significant role. Okay, I think we've got one more question, the last question, I would think. What challenges might we face using transfer learning to boost our poverty prediction models with satellite images and survey data? And how can we tackle them? Okay, by existing model, I refer to a paper by, okay. I'm not very familiar with that paper, and I'm not very familiar with poverty prediction modeling either. But I think, as you say, it uses a lot of heterogeneous data. You're talking about satellite images and survey data and so on. And India, and as is the case with any global South country, is a very complex demographical ecosystem. So I would think that there is a lot more to do with how these different kinds of data get fused, get merged up, and in order to inform a particular decision or more other kinds of decisions. But I would think, Anand, you should also maybe look at things slightly more broadly, right? I mean, in the sense, like poverty prediction models, are they accurate? And if they're accurate to 90%, we shouldn't stop there, right? Because 90% is still saying that you're classifying 10% of poor people as non-poor and denying them benefits, right? So we're actually looking at fairly nuanced kind of area. So I think it's a very challenging area, and I think I'll leave it at that. I hope it was of some use.
Praveen sir, can we conclude?
Yes, yeah.
Praveen sir? Okay. So as we come to the enlightening session to a close, I would like to extend my heartfelt thanks to all who made today's event possible. A special thanks to you, Dr. Deepak P, for delivering such a thought-provoking and insight talk on AI, a critical introduction. Your expertise and perspectives have provided us with a deeper understanding of the ethical and political dimensions of AI. I would like to express my sincere gratitude to our Honorable Vice Chancellor, Dr. Sajid Gopinath sir, for his continuous support and guidance in all our initiatives. A big thanks to our registrar, Praveen sir, for his invaluable support in organizing this event. Thank you, sir. Thank you very much. I am pleased to announce that our next expert talk will be on August 4th by Dr. Janet K. Allen and Dr. Farouk Mistry from Oklahoma University, USA, on the topic Cyber Physical Human Systems Research Opportunities. All are kindly requested to join this talk as well. Thank you. Thank you once again, and have a great day ahead. Thank you.
Thank you very much.